Assalamualaikum warahmatullahi wabarakatuh. So my name is Nini Syaheera binti Jasni. I am semester 6 with ID number 2019934347. So I'm presenting low salinity water flooding investigation using different type of radioactive tracer in vertical sandpack configuration. So the introduction that the primary method of oil recovery only recover 12 to 50% original oil in place, and then we are using secondary recovery method takes place over the primary method to increase the oil production. So the secondary recovery method is very cheap, and also the tertiary method is very expensive, even though it can produce a lot of oil recovery. So the fluid which is we use formation water, and oil we are using kerosene. Sand we use from the sand from Pantai Bagalalang, and the tracer we are using gallium 68 and also technetium 1990M. So by using water flooding, secondary recovery method, since I telling before that secondary recovery method is very cheap, and also for the low salinity water flooding, because of the injection of to improve the higher oil recovery compared to injection with the higher salinity water. So the tracer, the overall water oil injection pattern from developed RTD model we develop after we are injecting the tracer. We can see from the RTD model, and also it can also characterize invisible rock formation, and then the type tracer is gallium 68 and technetium 1990M. So problem statement: the physical simulation using vertical sandpack is very limited. Not a lot of research have been done for vertical method, usually horizontal method. So the second one is primary method and tertiary method. Primary method is very low oil recovery success, but tertiary method is very expensive. That's why we are trying to use secondary method. So the lack of the characterization to see the pattern of the water flow says that for the old one, without using tracer, we cannot see the water flow. After we are using tracer, we can see the water flow from the tracer method. So the objective is that to study the efficiency of recovery of vertical sandpack with different low water salinity, and the second one to study the variation of tracer in water flooding. So the scope of study for the objective one, we are using FESEM, which is analyze the mineral in sandstone and scan by field emissions scanning electron and microscope. And then we have preparation of brine and sweep efficiency for the injection objective 2. We are using gallium 68 tracer and injection of technetium tracer. So for the methodology of objective 1, so after we analyze the FESEM, we can see the component, which is carbon, oxygen, nitrogen, aluminium, silicon, chlorine, and pyrum. For the preparation of brine, so we are using formation water, which have sodium chloride, calcium chloride, magnesium sulfate, and then brine, which is sodium chloride. So after that, the brine formation water was prepared in the room temperature. So next we are using efficiency. This is how we prepare, and also this is our setup. So but this is sandstone. We can see the 32 cm lamp PVC column, and the injection of variation is brine is 200, 300 ppm, 500 part per million, and 5000 part per million. So methodology of objectives 2, injection of tracer, injection of gallium 68 tracer, and injection technetium tracer. So this is how we handle the tracer. This is from where we injection, which is 1 meter, and this is our setup from the picture, and this is our next setup before we injecting the tracer. So this is a flow of the process. First, we are set up the sandpack, and then we clean the column with the sandstone from the Pantai Bagalalang. So this is the setup sandpack, and then the length is 32 cm, diameter 5 cm, drainage area is 19.63, thickness is H30.80 cm. So this is how we are set up. So this is a formation water flooded in the column. Then after that, we calculate the porosity. After calculate, we oil injected into the column, and then we flood it with the sodium chloride brine, and then residual oil collection data was recorded, and then by using tracer volumetric sweep efficiency. So after that we are using vertical Sandpack. After we done for the brine, we get the lowest one is the highest oil recovery. So we are using the tracer injection. So this is how we inject. First with technetium 1980M, and then we inject the brine. After inject the brine, there is a detector over there, so it will flow to the Sandpack, and then it will flow through the detector, and then the effluent, so the detector will detect the flow of the technetium and also the flow of the brine. After that, it will go to the data acquisition system, and we through the laptop we can receiving the data. So this is a methodology. This is our formula, how we calculate the data by oil recovery extracted over origin oil, drainage porous, volume equal to drainage area time H and the porosity, and sweat volume peak over 0.75, sweat efficiency, sweat volume over over VDP, and then the analysis RTD model and sum of square error. So this is the result of the objective one. This is the result. We can see that 200 part per million can collect a lot of oil recovery instead of 5,000. So the sodium salinity of 200 part per million show the highest recovery as compared to 5,000 part per million with lowest oil recovery. The vertical configuration need to counter gravitational force instead of the horizontal position to show the massive difference when differentiate between all reserves with the same salinity. We can see the vertical configuration and horizontal show the massive difference, and then the yield higher percent oil recovery at a total average is 61.02 oil recovery percent. So this is volume to efficiency versus salinity. So from the 200, you can the sweat efficiency is much higher, and then 52.14, then instead of 300 part per million, 47.68, and for the 500 part per million, 41.42%, and then for the 5,000 is to 35.20%, which is the lowest than 200 part per million. So this is the salinity. So this is salinity is 200, drainage area is fixed, thickness, porosity, drainage porous volume, and community production peak, and sweat volume, and sweat efficiency is 52.7%. This is from the volume efficiency, and then after that we injection the gallium 68 and technetium by fluoride 3.5, which is fixed, and volume formation water is 329 and 335. Activity of tracer 90 and 120, saturated oil 180, 188. So the difference in efficiency value could be due to the downward gravitational force. So retention time distributions, gallium 68, the results are puzzling and is suitable for sand tracking and not for liquid tracking and monitoring, and Nini was best described by the perfect mixture in the exchange of model. This model is indicate the presence of two zones inside the Sandpack, which are primary zone and dead zone respectively, IAEA 2008. So this is how when the model is success, it will fix the RTD model over here. So next, the result for the gallium 68. After we injecting, we can see the gallium 68 is not suitable for sand tracking. It's not suitable for liquid tracking, since that we are using liquid tracking. So the results are puzzling. So after that, you can see the tracer, there is no signal due to it is suitable for 68. Tracer gallium 68 was absorbed in sand particle, and the result are puzzling. The modification of existing gallium 68, and then we chelated with the OTA. Since that gallium 68 are not suitable, so we are come out for the technetium. So this is the technetium. It's a bit puzzling over here. I mean, like a bit of the graph is not really follow the flow, but because of the channeling is detected during the chemical process, and This is due to flow of preparation of the sandpack are not really well packed actually. So this introduced the several channel that disperse a brine tangled tracer during water flooding. So from the result, we can see the percent of recovery 66.7. For the technicity is 60.1. Since the RTD model for the Galaxy 68 cannot be seen because there is no signal, because this is sand tracking. So only technetium can reflect the RTD model, which is perfect mistake in parallel model. The sum of square error SSE doesn't have any error because there's no signal and even cannot do the RTD model. But then in the technetium 1.39 times 10 negative 9 the error. As conclusion, the oil recovery efficiency sodium chloride salinity of 200 part per million show the highest recovery as compared to 5,000 part per million with lowest oil recovery. Different arrangement provide different yield of discovery. Horizontal arrangement of the sandpack column produce better yield of oil and the utilization. So for the RTD model can provide the exact explanation of why the recovery of oil is not optimized during water flooding activity, and the Galaxy 68 is not suitable in liquid. Independently is a sand tracker. Technically is easy preparation as it's also well blend in liquid form, and the SSE is much lower than Galaxy 68. So for the Gantt chart, this is the Gantt chart during the year. So you can see the registration during 2018 and the different December, and then thesis writing. So this is where I had take study leave and continue back to writing. This is where I take the study leave. This is where the submission research paper, and also I be present during the study leave. I also had taken the conference presentation, and also this still submission paper and still in progress. So I hope that is this is the milestone that I have achieved. So maybe during 2023 end of July, I hope the thesis is completed, and also this is already submit the paper. So this is experiment I have done everything, and research paper just waiting for the review, and also still in progress, and thesis only left for a little bit of add-on for reference and everything, and for planning status publication. So low salinity water project investigate using radioactive tracer in different sample configuration is in progress, and RTD modeling of water flooding of vertical sand column using technique to X-ray tracer is already published, and also investigate of water flooding in vertical sand column using gallium system also already published. So the planning compile the thesis and publish the article. Thank you so much.